Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Guled Mohamoud Yusuf. I'm going to make my video of case study project. This presentation is going to explain these topics: amplitude modulation, angle modulation, and digital modulation. Amplitude. So we are going to go first. The first topic, amplitude modulation. So here is the content is that we are going to touch in this topic. First, we're going to explain the definition of amplitude modulation, history of amplitude modulation application, and disadvantage of amplitude modulation. First, let's define amplitude modulation. Amplitude modulation is a modulation technique used in electronic communication, most commonly for transmitting messages with radio wave. This technique contrasts with angle modulation, in which either frequency of the carrier wave is verified as in a frequency modulation or it is phased as in a phase modulation. History of amplitude modulation. The first amplitude modulated signal was transmitted in 1901 by a Canadian engineer named Reginald Fessenden. He took a continuous spark transmission and placed a carbon microphone in the antenna lead. The sound wave is impacting on the microphone fried its resistance, and in turn this fried the intensity of the transmission. Although very crude, signals were audible of a distance of a few hundred meters. Although there was a rasping sound caused by the spark. With the introduction of continuous sine wave signals, transmissions improved significantly, and amplitude modulation soon became the standard for phase transmission. Nowadays, amplitude modulation AM is used for audio broadcasting on the long, medium, and short wave bands, and for two-way radio communication at VHF for aircraft. However, as there now are more efficient and confident methods of modulating signal, its use is declining, although it will still be very many years before it is no longer used. Actually, amplitude modulation have applications. Number one is airband radio, broadcast transmission, quadrature amplitude application, single sideband broadcast transmission. If we talk about advantage and disadvantages of amplitude modulation, first we are going to see the advantage of amplitude modulation. Number one, it's simple to implement. It can be demodulated using a circuit consisting very few components. Amplitude modulation receivers are very cheap as no specialized components are required. The disadvantage of amplitude modulation is not efficient in terms of its power usage. It's not efficient in terms of its use of bandwidth, requiring bandwidth equal to twice that of the highest audio frequency. It's prone to high levels of noise because most noise is amplitude based, and obviously amplitude modulation detectors are sensitive to it. The next topic we are going to talk about angle modulation. The quantities will be definition of angle modulation history, angle modulation types, difference between amplitude and angle modulation. So, angle modulation is a class of a carrier modulation that used in a telecommunications transmission system. The class comprises frequency modulation and phase modulation PM, and is used on altering the frequency or the phase, respectively, of a carrier signal to encode the message signal. This contrast this with varying the amplitude of the carrier practiced in amplitude modulation AM transmission. The earliest of the major modulation methods is used widely in early radio broadcasting. The history of angle modulation. Angle modulation was the earliest modulation method used for transmitting audio in radio broadcasting. It was developed during the first quarter of the 20th century, beginning with Robert Landell, De Moura, and Reginald Fessenden's radio telephone experiment in 1901. Types of modulation: frequency modulation and phase modulation. So if we go first the frequency modulation, number 1, frequency of the carrier is directly modulated by a modulating signal. Modulation index is increased as modulating frequency is reduced, so they are inversely proportional. The phase modulation, number 1, phase of the carrier is directly modulated by a modulating signal. Modulation index does not depend on modulating frequency. The difference between amplitude and angle modulation. Amplitude of the carrier is varied according to amplitude of modulation signal, while the angle modulation frequency of the carrier is varied according to amplitude of the modulating signal. Angle modulation, amplitude modulation has a poor fidelity due to narrow bandwidth, while angle modulation, since the bandwidth is large, fidelity is better. Most of the power in amplitude modulation is carrier, hence less efficient. In angle modulation, all the transmitted power is useful. If we see in amplitude modulation, noise interference is more, while the angle modulation, the noise is minimum. The amplitude modulation, depth of modulation of the amplitude modulation have limitation. It can't be increased above 1. But other hand, in angle modulation, depth of the modulation have no limitation actually. It can be increased by increasing frequency deviation. So, next topic we are going to talk about digital transmission. So, techniques in digital transmission. There is 3 techniques in digital transmission: amplitude, frequency, and phase shift. So these 3, the phase shift is the new method introduced to digital transmission, where we will see the new method also. In digital modulation, the main difference with the previous modulation is only that the main difference with the previous modulation technique is only that the carrier signal is in digital form. So if we see the first waveform, frequency is changing from low value to high value frequency. We also see that there is no phase shift in the frequency waveform here. Next, if we go to waveform of amplitude shift, we are noticing that the amplitude change from low value to very high value. This translates into the carrier signal for low amplitude value into digital 0 value, and higher amplitude means high or 1. The next, the phase shift, the new method we already talked about. This new method introduced to digital transmission, we found that the first waveform, actually the phase is constant, and the amplitude and frequency are the same throughout the whole wave. Advantage of digital over analog transmission: bandwidth, high data, it means high data transmission capacity. Noise immunity, actually digital data is less susceptible to noise. Power efficiency means that the system requires less power in digital transmission. So quadrature, we are going to talk about the last topic. Quadrature modulation is a modulation system which allows the increase of the bandwidth of the transmission by modulating two carrier signals in an amplitude modulation with a phase shift of 90 degrees, then combining these two carrier signals together. So as we see here in the below the picture, this we have different systems: 4 QAM, 16 QAM, and 64 QAM. The first picture on the left, this system is called 4 QAM. This system contains actually 4 dots. These dots represent one single data in the carrier signal, but actually each dot carries 2 bits of data. For example, 1 0 0 0 0 1 1 1. If you analyze 1 bit of transmitted modulated signal, you will get 2 bits of data value. The next system have 16 QAM. Each dot have 4 bit data or value. So this system is called 16 QAM. The next system, which is more complex than the other two, because this system will be carrying more data. So this system is called 64 QAM. Yes, it's going to carry more data, and actually, of course, it will have a wider bandwidth due to because it's gonna transmit higher capacity of data, and so on. So you can upgrade the system to get more data transmission. So thank you so much. We reached the last part of the video. Thank you so much for your time. Assalamu alaikum wa rahmatullahi wa barakatuh.